Welcome, guys. I managed to go to take a power nap and I woke up 2 hours later. That was terrible. Obviously chronical lack of sleep. Let me just share this. While we hit an error in fuzzy and focusing on HBS LID detector. Okay, that's the plan for this stream. Let's see why I'm getting this weird error. Let me just turn on the live chat. Okay, guys. So I managed to hit some error in one of the runs. Let me see. So one of them is almost completed. Two of them are almost completed. But this one, wait, why is this 0.63? And yet we hit the error in the fuzzy stage. That's weird. How did we get it? How did we even get here? I guess that's the question. Okay, that's weird. Let's see which min hashes did we save so far. So min hashes, Serbian Cyrillic. Oh. Oh, this is... Okay, we might have a bug. Because I'm dumping everything in the same directory. And yet... Yeah, we missed some prefix, like dataset prefix or whatnot. But how did Serbian Cyrillic end up here? Bosnian, Serbian Cyrillic is, according to this plot, not yet over. And yet we somehow hit that line there. That's weird. Why would that happen? Serbian Cyrillic entered the fuzzy dedupe. Super weird. Okay. This is the output file. And then later when we are running the yield, whoops. We grab anything that has this pattern. Okay, fair enough. So at the moment, we are dumping, let me see. we're going through the data sets. Running the min hash worker, which is just doing this. Huh. Well, it should work. We have global offset plus document offset. This is actually good. We don't need to do anything else. I did handle this already. Let me see quickly here. Why do we have only 1 million here? Probably because the filtering was very, very strong for Serbian Cyrillic. So let's go. Let's see. Let's exit here. Let's see the count. The dataset count for the corpus name. Total after. Okay, to get the number, let's do it like this. So let's go iterate through the values. So for element in values, and then just grab element total after and save that into a temporary variable. And then sum. So this is the number. And is that number the same as what we get here in the min hashes? Let's see. So again, Serbian Cyrillic. Yes, looks like we're just there. So, okay, that's weird. The good thing is we can easily analyze these dumped min hashes and see whether we have all of the IDs. Let's do that. Let's quickly analyze what's going on with these min hashes. One thing I'm confused about is why is Serbian Cyrillic here only at 0.631? Okay, maybe I'm misinterpreting something in just a second. I see some toggle down plots here. Okay, everything is toggled off except for these three. Yeah, this is weird. Why did they stop at 2.5 million? What's going on? Okay, let's quickly analyze this. I'm going to create a Python file right in here. Well, actually, let's be a bit smarter. Let's not make it there. Let's just make it somewhere in here next to filter. Temporary file. Now grab the root location, this one. And then something like this. Of course, we have to import the OS. File path is going to be join that, and then read the pickle. And as well here we have to import pickle. So we have now the min hashes plus the IDs. So let's extend those. Okay, let's see what we get here. Okay, looking good. And then at the end, grab the element 0 and then sort. I'm not sure whether we can do it like this. And then, okay, let's just do it like this for now. Okay, keep run. Rerun again. Let's keep running. Let me see whether somebody's asking any questions. All good. One 906,716. If I recall correctly, that was the number I previously found. In here. Was it? Okay, let's make sure this is consecutive. Like there is no duplicates, and it's just going to from 0 through whatever the biggest number is, which is this minus 1. Hopefully. Let's see how we can deal with this. Okay. Range of length of offsets, and then assert that depth is equal to offsets. Rerun this. So this should be equal to this one. So we load all of the min caches, we sort them, and we make sure that when we just grab the length of that array, that 0 through the length minus 1 equals offset. So that means this is consecutive. Seems it is. Fair enough. So if that's the case, then a couple of questions. First, why is the weights and biases plot at 0.6 something? Let's go to filter. Why is this before fuzzy stopped at, why did it stop at 0.6356? Total before. Over total number of lines. Definitely not clear what's going on. Okay, let's put a breakpoint somewhere here. This is currently at 22 million. Whereas the total number is 45. Wait, how? How is this even possible? Because we're still dealing with primary. Okay. What about the other one? 15 million. And we are only at 97. How come is this only at 97,000? Why is this so slow? Why is this one so slower than the other ones? Okay, there is definitely something that needs to be understood here. Why is one of the processes so much slower? So this is either Bosnian or Croatian. This is Croatian. Then the other one is Bosnian. And for some reason, Bosnian is super slow. Interesting. So a couple of questions left for us. Why is one of the directions much slower than the other two? And the second question is, why are we hitting error when attempting to remove from LSH? What's up there? So we pass in the self LSH and we modify it inside of the build LSH parallel. Huh. Weird. How come is Bosnian at 0.9? Nah, this is complete gibberish. Bosnian is at 40 million on the x-axis. Yet when I was putting a breakpoint, I was getting different numbers. $185. What is going on? And that's Bosnian. Okay, let's just put a breakpoint here. Okay. What direction is this? Bosnian again. Total before 186. That's the step. And yet, looking at this one, something is off with these plots. Something is completely off here. Everything is wrong. Everything is wrong. Like, this is not at 100, this is at 40 million, but it's not at 40 million. This is just a complete BS. Aha. Wait. No. Okay, this is... Guys, this is a bit different story. Because I'm looking at dataset counts, but I'm not looking at the counts. Let's see the counts. That's what matters. So let's go and see the counts. So temporary equals for element in the counts values, grab the element total before, and then just sum it up. And that's equal to 4 million for this particular direction, which is probably Croatian. 4 million plus the running one is 17K. Do those numbers make sense? Croatian. No, this says 2,289,000. And then it says that's only 0.5%. Huh. Still weird. Okay, I see what I've done. We have a complete... This is completely mistaken. So to get the steps, we have to grab the counts so far. So to grab the steps, let's create a small function, helper here function here. Get step, and we pass in the counts, and we pass in the current datasets counts. And then what we do is exactly what we've done above here. We go through the counts, we sum them up, and then exactly. So this is the number we should be getting. This, and also here, not this, but instead this. And then here, not this, but instead this again. We messed up completely there. Now this should be good. Okay, I messed up. So I'm thinking whether I'm just gonna stop this. Unfortunately, we kind of lost a bit of work there. Not that much, so all good. Still just iterating it. Okay. Let's just make sure this works. Kick off the run. Okay. There's some So this should now work perfectly. As we are going over different data sets, ultimately we will have counted all of the lines in all of the data sets, which should be same as this number here. So we should get to 1 on the y-axis. And then the question is, why did we hit an error here? But while we are waiting to get to that stage, okay, we figure out this. See how we can train the HBS versus non-HBS lang ID. I think we discussed this previously on in the chat, so I'm going to quickly scroll up. And see what did we discuss on that topic. I think Chris has mentioned some things. Okay, here is, I think, where we discussed the LID. Okay, let's go back down there. Let's find the first discussion on the LID. I think just below this here. Okay, this was for the tokenizer actually, not about the LID. Okay. That was the main message that Chris had. I think these systems should be fairly easy and quick to train. Like in order of minutes. Okay. Let's open up the different repo, sec, and let's maybe analyze the existing LID systems we're using. Let me see, open LID, GitHub. supports 201 languages. Serbian Cyrillic, Bosnian Latin, Croatian. And this tells us what? The number of sentences they've used to train lines of training data. So for Croatian, only less than 1 million. For Serbian, even less so. For Bosnian, even less so as well. So in total, only around 1 million lines. That's super small. And then they report some numbers here. The first one number is F1 score and then false positives. Serbian has too good of a score here. No false positives, and that's weird. How should we interpret this? Let's see how they train this. Okay. Let's see how to train this. Why is my Chrome white? I like dark mode. Models, requirements, building the fast text. Use cases. How do we train? How do we train a model? Word representation learning. Okay, I guess that's what we need. This is what we need, a text classification. So we just need to run something like this, fast text supervised. Pass in the input with labels. For us, the labels are gonna be the language codes. So let's go quickly to the fair sec. Let's find the analyze data. script. And let's go to the LID. And then pick the LID here. Okay, let me just quickly close and open up because linter is dead. Okay. Okay. LID. Analyze data. Let me just see what I've set in the long JSON for analyze data. HBS. Okay, fair enough. Run this. LID worker.